Hello, guys. Welcome to our second class of number patterns. Now, we are looking at geometric sequence. So, remember what I have said when we are referring to T1, T2, T3, or maybe T4. We are saying there should be a relationship and we must be able to pick that. How do we check that? In this case here, for geometric sequence, we see that if we divide T2 divided by T1, it must give us T3 over T2. Okay, so here is our T1, here is our T2, here is our T3, here is our T4. So now if we say 4 divided by 2, what we'll get here is going to be T2 over T1, which is going to give us 4 over 2 is going to give us 2. Okay, then if we divide this T3 over T2, what we'll get there is going to be 8 over 4, which is going to give us 2. It goes on like that. 16 divided by 8 is going to give us also 2. So we refer to this as our constant ratio. Okay, so this is our constant ratio. This is our R. Okay, so in the general formula that we'll be using in this case here, we are using Tn. To get Tn, we say A times R to the power n minus 1. So what is our A? Our A, like arithmetic sequence, our A is always the first term. Okay, so it's always T1. So that's our A. So this is our A. Okay, so we don't need to stress much. So what do we need to do here to get the general term? We substitute what we have. We know that we have got A here. Our A is equals to 2. Our R is equals to also 2. So how would we get the general formula in this case here? Tn is therefore 2 times, you can put a dot there, 2n minus 1. Okay, so let's look at the 11th term. So in this case here, we are given n is given to us, and we are looking for Tn. So n here is actually 11. So here, when you're looking for T11, we're going to say T11 is equals to, we put where there's 11, where there's n, we put 11. So it's going to be 2 times 2, 11 minus 1. Okay, so in this case here, this is going to give us 2 times 2 to the power of 10. And what you do here, you come to your calculator here, 2 times 2 to the power of 10. What do we get? We get 2048. So this is our answer, 2048. That becomes our final answer like that. Okay, so that's how we get at our 211. And always remember, we can't say 2 times 2. Always remember, we can't say 2 times 2. So always deal with these two separately, because this is an exponent, so it's on its own. So I will just have to put the what call, and for you to remember that this is working on its own. We can't mix these two. Okay, because some of you will say 2 times 2 is going to give us 4, then 4 to the power of 10. That would be totally wrong. Now let's move on to the next one here. Which term equals to 5,536? And remember what we said in this case here, this is our Tn. And what are we looking for? We are looking for n. So we write our formula here. Tn is equals to 2n minus 1, like that. Okay, what are we given? We're given Tn, and we're going to substitute there. We're going to have 65536 equal to 2 times 2n minus 1. Okay, then what we do here, we want to get rid of this 2 here, because this 2 is multiplying this 2. So we're going to get rid of the 2, and what we do here, we divide by 2. Then we cancel there, and if we are to take here your 65536 divided by 2, what do we get? We get 32,768. Okay, 32,768. Okay, which is going to be 2 to the power n minus 1. Now, remember here, I don't know if you still remember, but when you're dealing with this kind of problem, what you just do here, when you have the value there, you just say shift fact. In this case here, it will give you the actual exponent, so the prime factors of that value. So in this case here, whenever you're looking for, let's say you want to write it first, just type it 32768, and what we do, we just say equals to, then you say shift effect. Shift effect is here, then you can see that is 2 to the power of 15. 2 to the power of 15 is equals to 2 to the power of n minus 1. Now we refer to this according to the exponent. These are our bases. So once our bases are the same, it means that exponent also will be the same. So the exponent here will be 15 equals to n minus 1. And when you take 1 that side, n is going to be equals to 16. So our answer there is going to be what called 16. Okay, let's move on to the next problem. Now, so actually this is the end, but there is another problem here. Let me just check my slides, just a moment. Okay, let's move on to the next question. Here is T1, T2, T3, and we are told that we know that in this case that is geometric sequence already, but in this case here, if you are given the question just without knowing the sequence, you need to divide. So you're going to say this T2 over T1, T1 is going to give you 0.2 over 1, which is going to be 0.2. And if you say also T3 over T2 is going to give us 0.04 over 0.2, which is going to give us also, what is it, 0.2. Okay, so in this case here, our R will be equals to 0.2. What about our A? Our A is first term, remember? First term is our A, so we just put it like that. And what is our general term? We know that Tn should be equals to A R n minus 1. What is our A? Our A is 1. What is our R? Is 0.2. What is our n minus 1? Is just n minus 1 like that. Okay, so it means that it's going to be 0.2 n minus 1. Okay, so that becomes our final answer like that. Now calculate the 11th term. The 11th term here, we're going to say, why am I saying 11th term again here? Let me just change this, maybe to 9th term. 9th term. So in this case here, we are looking for Tn. So we're going to say Tn, we have the formula here, Tn is equals to 0.2 n minus 1. And in this case here, T9 is going to be equals to 0.2 9 minus 1. And what do we get there? Let's find out. So we're going to say 0.2 to the power of 9 minus 1, which is 8. Then we get 1 over 39625. 1 over 39625. Okay, so that becomes our final answer. You can see also, you can also put it in this way. It's up to you, but that's our final answer there. Now, which term equals to 0.00? We can see that we have 4 zeros here, then 1 to 8. So what we need to do here, we can simply say, okay, what is given to us is Tn. In this case here, Tn, and what we are looking for here is n. Okay, so what we are going to do in this case, we're going to punch this in the calculator. So whenever you're given this decimal, try to punch it in your calculator and see what you get. If ever you get a fraction, that will be the best. So here, 0.0000, then 128. Let's punch it and see. So it's a fraction. As you can see, we have got 1 over 78125. So here it means that our Tn is equals to 0.2 n minus 1. And here we say it is 78125. 1 over 78125 is equals to 0.2 to the power n minus 1. We are looking for n, remember, and in this case here, we are going to say, okay, we are given this value here. And when we are given this value here, we can simply get the factors of 78125. So 78125 is going to give us that. Then we say shift effect is 5 to the power 7. So here you can simply write it like this. 1 over 5 to the power 7 is equal to now 0.2 we can also change it and see what is it. 0.2 we punch it like that is actually 1 over 5. So it's 1 over 5, and this, remember, 5n minus 1. Okay, so according to your exponents, this means we can just simply say 1 over 5 on the left to the power of 7 is equals to 1 over 5, what is it, to the power of n minus 1. Okay, now once we have the same base, what do we do? Same base. What do we do when we have the same base? Same base, we equate the exponents. So in this case here, our 7 is going to be equals to n minus 1. We take 1 that side. N is going to be equals to 7 plus 1 is going to give us 8. So our value there will be actually, what is it? Our answer there will be 8. Okay, so that's what you should do, guys. Whenever you have same basis, that's what you apply when you're dealing with geometric. Okay, you know how it goes with me. These are your questions to practice with, and please kindly send to me so that I can check if you're coming right. Don't forget to join our Google Classroom and get access to, don't miss the class, and also get access to the PDF file. Okay, thank you so much. Until next time.